Hello, I'm Jinxuan. So welcome to my talk. Today I'll be sharing how to do DataFrame diffing. I'm currently a software engineer at 2 Sigma, a hedge fund. So before we started, I have included this disclaimer slide. So just in short, don't buy any stock or make any investment based on what I'm saying today about DataFrame diffing. So I've included because as a hedge fund, we're by legal have to do that. Cool. So a little bit more about me. So I'm currently a software engineer in the data engineering department at 2 Sigma. So we're we're a hedge fund that use a lot of data to help us make investment. So before joining 2 Sigma, I was in Bloomberg, and I've been in the big data since 2015. I was first from ASU, Arizona State University's Data System Lab. And back then, I was part of a research project that I think right now is graduating into a project called Apache Spark. So this is if you're dealing with geospatial data, check it out. We even have a commercial company called Robot that supports it by my professor and my classmate back then. Also, I'm a huge fan of duckdb. I think it's one of the most exciting tools and ecosystem that we have in most recent years. I'll be talking about how to use duckdb to DataFrame diffing in my talk today. Cool. So that's about me. So for today, I'll be talking about called DataFrame diffing. First, I want to give you a story. This is coming from my DataView work. As I mentioned, I'm a data engineer. So a lot of the job that we have is doing data pipelines. And these data pipelines involve dealing with a lot of file parsing. And in financial world, a lot of this file is just CSV, and historically have a lot of code that just PD.CSV that returns a data frame, and we do all the data transformations. But we have a big project this year to just upgrade the Python, the pandas major versions from pandas 1.5 to 2.0. Imagine you have a CSV file like this. I just take 01, 12, 2024, 01, 13, 2024, something like that, right? And note that if you does not specify a date format, and you just let the pandas to infer this for you, you will have a different behavior. So look at pandas 1.5. Historically, just do the right thing, like just infer it to be January 12th. But it could also be December 1st. And this kind of bug is actually pretty hard to infer unless you read around the code. And the way we found this is in the process called diffing, and you can replace it as a comparison. Find the difference between two data frames. So that is the problem we're talking about. So before we talk more deep into it, let's just define what are the main two concepts in this data frame. So the data frame I'm talking about today is not limited to like just pandas data frame. Just any two-dimensional data structure that consists of rows and columns that you can read into memory and treat it as tabular data. Like whether it be CSV files, TXT files, or spreadsheet, or your pandas data frame, BigQuery, Google BigQuery table. Yeah, we're talking more about a general data frame. And diffing. Diffing is the comparison between data frames. So I think a lot of people here have been using Git as a version control while you're writing code, right? So a diff in the Git is a version comparison between text files. And we just add one dimension to it to diff between tables or data frame in this scenario. Here's a very simple example. We have two data frame. And you can see that they're mostly the same, aside from the B1 cell and the C2 cell. And a diff is just highlighting the difference between them. Okay, so why can't we just use a very simple function, or you can just, for example, write your own, write something like a df compare, or just directly using existing tool like pandas, like testing the assert equals. Just returns a boolean that tells you, okay, whether these two data frames is the same and what's the difference between them. It turns out it might not be that easy. I'm going to talk a little bit more challenging here. The first is data-frame diffing. I want to say it's more like finding a needle in the haystack. So the left image is after 20 rounds of chat with the ChatGPT, because I just really want to ask it to generate a needle in a haystack. But after many failures, because ChatGPT just keep wanting to make a giant needle stuck in the middle of the haystack, and no matter how hard I told him to make the needle smaller, make the needle smaller, he always have a giant needle in the middle. And in the end, what I choose is let's add a magnifier. That's what you see right here. Okay, this magnifier is actually the data-frame diffing we are talking about today. We're trying to find a needle in the haystack, but especially when you have a big data size, we want to find the one or two discrepancies in a million rows. Okay, but not only that. I know big data is where everybody talks about is difficult. There's more nuance. For example, schema complexity. When you're doing data-frame diffing, if everything is very standard data types like integer, string, etc., that could be save time a little bit. But what if you have a nested data structure? You have a data frame that is type is a JSON, right? How do you do a different diffing on that? What else? When there's some more, I would call it the details or nuance that you need to consider when we're doing a data-frame diffing. For example, when you're even with the basic types, like float, you have double versus float. What is the precision, right? And in terms of the null, just take pandas as an example. You can have n, which is not a number in pandas. You have none as a Python type. You can also have 0 could also be representing a null in a data frame. Imagine you're using some text file like CSV. So those are actually pretty, in terms of data-frame diffing, you have to have a deep understanding of that to make your decisions. The last thing is is the data frame sorted by some key? If they're sorted by the key, does the order of the data frame rows matters when you're doing that? So this is some of the challenges that makes this problem of data frame diffing not that easy. It's so you can't just write a very simple function or statement that df1 equals df2. Okay. So before we talk more about the data frame diffing, I want to just share some what are some misconceptions people might make, and this actually just carry over from the previous slide, the challenges. So the first thing I want to say here is if data frame is not exactly matched, it does not mean they are not equal. To explain, I have to give you two very simple examples. So assume you have a string on the left, which is 20.411. That usually means January 1st, right? And then you have another one on the right side. You have a pattern with a 0. They're not matched. They're not exactly the same. But semantically, they both could be referenced to January 1st at the date time, right? So this is an example. And similarly, even given the same timestamp, one is time zone aware, the other one is not time zone aware, which is a UTC. You just say it is matched or not. You have to make the decision, right? So that is the first misconception, that even if you have data frame that is not exactly matched, that doesn't mean they're not equal. The second one is doing data frame diffing. You might be saying this, this is not easy, and then I think this may be a very, very resource-heavy operation. I have to use very complicated tools like Spark and using distributed computing to process the files. And my answer to this is, if your data size is not like hundreds of terabytes, usually means you don't need very, very resource-heavy operations to do this thing. And I will talk about in the later slides. Okay, cool. So we just talked about DataFrame diffing. What can it use for? I think first again, as a data engineer, it can help us do data validation when doing things like library version upgrade, as an example I shared before. Can help you guarantee data quality, right? And more importantly, if there's any data issues happens, it helps you to explain the data frame different discrepancies or have a quantitative. Okay. In the next section, I am going to talk about some preparations. So there are some questions that you need to think before doing that diffing. So the first question I have here is, I might choose the right storage system. Okay. Even though we're talking about a logical representation of data frame, like no matter what it is, but choosing the correct storage system or storage format will make your data frame diffing a lot easier. If the data frame is stored in the database, that means we can directly run SQL for it. That's good. If the file is already in a very in Parquet format, which means it already has schema and some metadata related to this file, this will make your life easier. The thing you don't want to do is directly diff on a text file. I already show you. If you just directly use pandas to read the text CSV file, you will go bite for that because it will make your life easy. You do a different diffing, well, direct on text file, well, not that easy because of the schema information. So choose the good storage system before you do that. The second thing is, do I understand this data, right? So before you're doing the different diffing, you may be able to have some high-level analysis, right? So you can just get the shape. If two data frame, like the number of rows and number of columns, they already have big difference, then probably before you dive in, you already know they're not equal, right? The second thing is, aside from the basic information like the total number of rows and total number of columns, you maybe can do some aggregations and then do the diffing. You can first see, do I have some key columns that I can use to group by? And if I have those key columns, can I just group by those keys and count the number of rows for each group, and then do the diffing? This can give you at least some better understanding about the data, whether at the group level, whether we have some differences or not. And next is the schema. Is the column name exactly the same? Can I normalize the columns, remove some special characters, normalize it to all lowercase, so that they're comparable? What are the column type? Can I standardize all the floating numbers into like double 64 so that I can make my comparison more comparable? And standardize the null values, right? So by answering this question to have a better understanding of the data can help you do the data frame diffing so that you can really compare apple to apple, pairs to pairs. Next is when the data size is big, do I need to partition my data, right? If you have like 100 gigabytes, and you have some partition key, like if you can partition by day, partition by year, like in computer science, we have a problem. The usual way of studying is, can I divide and conquer it? So if the data size is big, you may have this question: can I just partition my data, pick some partition key, and split them, and then do the diffing, partition by partition, right? So pick a reasonable partition size. I would say like usually like if you have the megabytes level, that would be the most ideal, so that you can get into your laptop or even your service. Okay, the last thing, the question I have here is, can I just pre-process the data? After we have a deeper understanding, after we have prepared the data, like so that it's in a reasonable size, let's do all the things that just pre-process the data, like normalizing the columns, standardize the null values. There's one more thing I want to here is add some trace information. So when you're doing a data frame diffing, you may want to add for each row, what is the file it comes from, like file path or file that this row comes from. you add some line number so that if you find a data frame diff, you can easily trace back to where it comes from. One last trick is I have here is doing data frame diffing is easier for you to do some schema transformations, convert from wide to narrow schema. So assume you have a data frame diffing that on two data frames that both have thousands of columns or even like tens of thousands of columns. That's from a visualization perspective, right? But you can't show 1,000 columns in your Jupyter notebook or like easily present it to your audience, right? So you can try to pivot your data frame on the key columns that you find so that you convert this from wide to narrow schema and then do the diffing so that you know exactly what cell is having that difference. Okay, so those are the 4 questions that I think can, before you really do a data frame diffing, can help you. And if you make good preparation, this can significantly reduce the complexity of your data frame diffing. Okay, cool. So next, let's talk about the real meat. Let's talk about some use case and tools. So all the slides afterwards actually have a Jupyter notebook presented as a slide. So if you open the link or scan QR code after the meeting, you'll figure it out. So for the presentations, I will just take the screenshot of those notebook and introduce here. So the first use case is let's just check if 2 data frames is equal, right? I already showed you that if you're using pandas, you can using pandas testing style assert equal. This works pretty well when the data size is not that big. Okay. Here is very simple comparisons. If you see the black highlight part is the code that runs it. Here we have 2 data frames. You can see df1 and df2 are equal, and the other one is not equal because the b1 df1 and df2 is 3 and 4. df3 is 3 and 5. Okay. But this, we just talked about pandas, and as we all know, like pandas is not very good when your data size is growing bigger. Usually, when you have million rows or the memory consumptions at gigabytes level, that is the time the panda is not going to handle it very well. I will have a presentation screenshot later. I want to introduce another tool that I found really useful is duckdb. So for a person that have never heard about this tool before, duckdb is in-memory database or in-process database that just enables you to directly run SQL on various data format. You can directly run SQL on file, CSV file, Parquet file, even a pandas data frame. Okay, just give you the flexibility to run queries SQL on that, and it's super performant. And here to execute a data frame to do a different thing, you can just using SQL to just select all the rows from df1 and accept all the rows from df2. This will give you the difference between df1 and df2, and you can just check if the result is empty. This is very performant, and we will talk about. I'll share that in a later slide. So I just show very two tools and techniques that just give you a short and concise answer about whether 2 data frames are equal or not. So now that assume that we know 2 data frames are not equal, how can we find the discrepancy? Which is like what are the rows exactly or the cells exactly are different? If you're using pandas or other tools, the first thing that will come into your mind is, can I just do a join on the data frame, on the columns that I care about? That is why in the preparation slide, I want to say you probably want to highlight your key columns. The worst case scenario is like you're going to use all the columns as keys, which is okay. But here is I'm using pandas as an example here. I assume I have 2 data frames here. The difference is the last row. You can see df1 has 3c, df2 has 3d. If you're using pandas and you do a join on both the key and the value columns, one thing that really helps you is you can add this this argument called indicator. By adding an indicator by doing a join by pandas, it will give you an additional column called merge, which has 3 types of values, either be both, or left only, or right only. Then the next step is you can just select the rows that are not equal to both, right? Or just equal to left only, so that can give you the discrepancies between your data frame. Okay. Yes, using pandas is handy, but what if you want to generate a report, right, to show you the statistics about the DF2 data frame? There is this library provided by I think it's Capital One. It's called datacompy. So they first they support multiple backends, and pandas is one of them. So datacompy is going to give us very simple API. It's called compare. That's just taking the data frame and provide the join columns, and it will return you a compare object, and this compare object will have a lot of utility functions. For example, you can select all the rows that are only on the left side. There's .df unq rows. You can also have a report function that will shows you first some high-level summary about like what are the rows and columns in both the data frame, and what are those columns that are in common, what are that rows that are in common. Datacompy has it's a very detailed report. I found this pretty handy for me to show what is the data frame difference between 2 data frames. They actually also show some sample rows that are only in one DF, not in the others. But because it's really long, I can't fit all of them into the slides. But in short, if you want to generate some reports, this tool is pretty handy, and feel free to check it out. And as I just mentioned, datacompy comes with multiple backends. Panda is one of them. They also support Spark, so that you can run on a bigger cluster. I think they also support polars, so that you can use it to do even larger data frame diffing. The next one, duckdb, the thing I like most. So duckdb, I think since version 0.8 or 0.7, they started to introduce a special type of join called anti-join. And anti-join is an exact syntax that's designed for solve the problem like data frame diffing. So what does anti-join do? So anti-join is to select all the rows on the left side. Here is df1 that are not in the that are not on the right side based on the join conditions. Okay, so it is exactly what data frame diffing is meaning for. Like before that, you can using the subquery that I showed earlier, right? But under the hood, but it translated to anti-join, and I really like this syntax. So you can see here by execute the code I have here, by anti-join on df2 on these conditions, it will return a df, which is only on the left side. Okay, and also just note that like all this df is just the data frame that I had in the previous slide as a panda data frame. So duckdb can directly run queries on those data frame in-memory object, which is pretty handy. So the third use case is because I'm coming from a hedge fund, so basically all of the data that we deal with is sometimes serious. I wanted to talk about a special type. I call it fuzzy temporal Data-Diff. So I wanted to give some context here. So assume you're trying to define some data set. They have some key columns, but the key column is not unique. Take stock as or stock market as an example. You have have a ticker, which is like, for example, Microsoft, right? Microsoft Corp. It's a ticker that they have a stock price of like every tick. So it's not unique. It's a time series. And when you're trying to do data frame diffing, and in this case, I structure the problem as follows. Assume I have some companies. They both have some time series data, which is we call it fundamental data. Each company they're going to submit their financial filings, usually like every quarter or at year end. So, and we have two vendors, right? So assume we buy data from two vendors. They are both like converting this data, but they may report it at different time, and we want to compare it. But doing a join on this is not that straightforward because you need to consider the timestamp. Basically, the use case is I want you to, given this company, I want to find the measure. Here is assume we're taking revenue as an example. I want to compare those revenue when they are the closest, right? Take company Y as an example here. So the first vendor they're reported on March 1st. The second vendor they're reported by February 28th. When you're using a data frame join, it might you may just, in this case you can probably just join on a company and then revenue, but the vendor they could have multiple updates to it. And when you're doing a join on this non-unique key, you will quickly exponentially grow, like make the join result very big, and then you do the filtering, which is actually not ideal. We have a special type of join called asof join that's just designed to solve this kind of problem. So that you can, before you're doing a join, you can align your data frame on some columns you specify, usually it's time series, so that you find the nearest. Okay. This has the following. Before you do that, like the data has to be sorted by the key you provided. So in pandas, you can use this pd.merge asof so that you can first align your data frame on the column that you want to. Usually it's a time series column. Here I'm just aligning on the filing date, and then join on the company column. You can choose directions to be forward or backward or just nearest, right? And specify a time rate that, okay, as long as they're within 2 days, I want to align them and then do the join. Okay. The output of this is actually shown as below, right? So we align the filing from company Y on this date so that we can really compare them. So here you can see that company A and company B, they're reporting different. Like company A, the vendor A reported 800 and vendor B reported 880. Those are the things that, yeah, the diff that we care about and we want to highlight. Okay. Yeah, but just to recap, like doing the merge asof, you have to make your data frame is sorted before you process that. Right? This is very important. Also, this function is contributed by Jeffrey Beck, one of our staff engineers in Sigma, that contributed to the pandas a couple of years ago. DuckDB, yeah. So I'm actually pretty surprised that DuckDB has we call it analytical database or AP. It actually helped spend a lot of time to optimize the time series queries. So they actually enhance the SQL syntax in their query. They literally add as a join into this SQL syntax. So which means in DuckDB you can using asof join two tables on the columns and provides the time series. Here you can see that I'm joining on the company and selecting the filing date. Okay, it's also very performant and enables to write SQL to implement the asof join. Cool. Yeah, let's go back to find that needle in the haystack. So I'm just creating a very simple dummy data. So using the schema I have presented in the last slides. So assume I'm having just generating 5 rows, both have 4 columns. I'm trying to do a data frame diffing using pandas and duckdb. And I want to see the part at the bottom. The left side was using pandas join to dip them. Given these 5 million rows, pandas is able to finish it in 12 seconds and use like 700 megabytes of memory. It reads the target file into a pandas data frame and do the join and then do the dip. And it finds the additional rows that I added to the data frame. Okay, but look at duckdb. How much memory and time it used? 0.01 seconds and 0.12 megabytes. What a stunning difference. Okay. You may be curious why? Because this is my personal opinion. Like every time when you have to do this operation, you can use it in a declarable language like SQL. You use that because then you can if you solve the problem in a declarable way, there's a lot of optimization can be done under the hood, right? So on the left side, 5 million rows, and when you convert into Parquet, that's a few 100 megabytes. Like you have to read everything into memory and then do the join and have all this row generated and do this is a huge scan. But in the duckdb, I directly do that at disk level. So duckdb is actually very smart enough to just read the portion of the data that it cares about and using multi-process to process it parallelly. That is why you see the huge difference, right? It's order of magnitude like 100. If you read different data that gives you a lot of memory issues, right? That usually means the data size is too big. Come back to the part that I talked earlier is prepare the data. Can I just repartition the data and improve the parallelism? Or assume your data is already in some cloud warehouse. You can use the same query that we had before to just execute on this warehouse engine like BigQuery or Snowflake, and it will give you the result. But me personally, I always prefer the first operation. Okay, cool. Some key takeaways for today's presentation. So the first, data frame diffing can be very complicated. Because of that, before I do the data frame diffing, make good preparations. And after that, remember the 3 use case. How do we resolve the data frame diffing? Is check if the data frame is equal, find the discrepancies, and if you have some timestamps, if there's timestamp data frame, how did you using faulty temporal asof join to solve that data frame? If you want to know more, I provide the link to the APIs for both pandas and duckdb. Cool. So that is all the topic that I have for today, and thank you everyone. And any questions?
Thank you. You showed the pandas and the duckdb both using the asof join and merge.
Yes.
And with the pandas one, you had tolerance and direction, but it didn't look like those options were available with the duckdb. Is there some sort of equivalent there?
Oh yes, like basically you just change the what you call the join conditions. Like in the duckdb, you can just I think the one I showed in the slide is less than, right? You can just use df2.date minus df1.date, like less than 2 days. That will be like exactly the same. So yeah, good catch.
Did you do any analysis of the same being with boulders?
Okay. First, I didn't do the exact analysis for this preparation for polars, but I can answer this question. So first is I go back about part of my presentation. This is my personal opinion. If there's a way that I can express solving a problem using something clever language like SQL, I always prefer to doing that instead of using using polars, right? Because in polars, basically you're doing like pandas, you specify really lower level operation. For example, in polars, depends on the data size. You may need to specify if I'm using a streaming mode, if I'm using like lazy evaluations, right? I prefer to like this kind of details to be delegated to like the professional system that does that. That's my first opinion. Yeah. Also, this is like the second thing is more related to the company because like my company invests very heavily on pandas, and bringing pollers is actually not that easy. I don't have experience like compiling Rust, like those kind of dependencies into some giant model. It's not easy. I've done that before. Like those compiling issues is very huge. And I think yesterday there's another presentation like that. Like they also have they share a story about that. So, but I have to say that Polar is a great tool, and if your environment is not restricted by that, definitely check it out. And I think also have good support about all the things that I have. But me, just like my personal opinion, if there's a way that I can solve the problem with the SQL, I want to use it in SQL to solve that.
Thank you.
Thanks. You started with the sort of the use case of having to deal with these upgrades, and so you needed to understand the impact of the upgrades.
Yes.
So it's a testing story.
Yeah.
But then you went into equal versus matching, right? The meaning of it.
Yes.
But really, like whether it's like semantically equal or not, it's the effect on the downstream systems that matters.
Yeah.
That's the impact. So how did you manage the impact of things whether or not they were semantically different?
Yeah, so this is basically the like iterative process, right? So you usually have to some high-level analysis to get a question like is other things equal? Then you do the detailed analysis, the result is perfect. Then you come back to if the semantic assumption that I made is correct, right? So I think the diffing is like a tool or techniques that help resolve that semantic difference as you dive more and more deep into the data. Okay. I hope that answers the question.
We can take one last question.
A question and an offer. What do you want the interface for viewing the diffs to look like, charts and summary stats, and would you be interested in collaborating on that?
In fact, internally we have a tool that just do the diff in output the diff in a more visualized way. Because it's pretty similar to what's the screenshot I showed here. Is basically just highlight what's all the difference are. Yeah, like something like this. So, but to be very honest, the way that I show here is I manually highlight that in the HTML. But yeah, I think once you've got the diff as an output, but in the DataFrame format, it's very easy to do whatever visualization that you think most viable. But again, I don't think that right now I have found a very good open source one that shows just show the diffing. Aside from the datacompy that prints out a text report, that is but personally I'm not aware of any good visualization like just highlighting the cell yet.
I'll talk to you afterwards. Thank you.
Okay, again, thank you everyone.